In this video, we're going to look at the data visualizations if we are doing a comparison. And in this case, we have 3 variables or more than 3 variables. So if you have 3 different questions, survey questions, then you have 3 variables. So here, if we have 3 variables, so 3 survey questions, and in this case, we have 2 that are nominal and 1 that is ratio or interval, we can create what is called a dot plot. If we have more than 3 variables, and so let's say we have 4, for example, and 1 is nominal, but the rest are ordinal, so the rest have ranking to it, we can look at the different rankings by that nominal group. And so we can do a comparison essentially of those 3 ordinal questions, but then break them into the categories from the nominal. To do this, we create a spider or radar plot. Spider and radar plots can also be used if you have 4 variables, 1 is nominal, and the rest are ratio or interval. So the key here with this spider or radar plot is that you have 1 categorical question or field so that you can do the different groups, but then the rest of the questions need to all have the same type of measurement scale, either all be ordinal or all be ratio or interval. So in this video, we're going to take a look at how do you create a spider or a radar plot and how do you create a dot plot in Python. So let's go to our code. Just a reminder, if you want to create these, we are in drstephpowers.github.io/BIA, and we are in the workbook called Data Visualization. You will also need the Excel files Bargain Clean, Bargain Numeric, and CRM Clean as we're working through these visualizations. So again, make sure that you link your Google Drive once you're in it, in Google Colab, and then you import those files. So see some previous videos for how to do that. That's of course at the top of this. Mount the drive, import the data. All right, so we are creating spider or radar plots. So let's go find those here. Scroll through the ones we've created in previous videos. Last time we created some waffles. There we go. All right, a spider or radar chart. A spider or radar chart is from plotly.graph_objects. And so because it's graph objects, we'll simplify it, call it Go. So import plotly.graphObjects and call it Go. Now what you're going to need to do is you're going to need to take, remember this spider or radar chart requires that your variables all be either all ordinal or all ratio interval except for the one that is the categories. So here we're going to do is we're going to create a table. We'll call it SPI for our spider. And we're going to pull from, this is our coded data table, DF2. And we're just going to create a subset. So we're going to create a subset that is question 13, 14, 15, 18, and 20. So let's just go back and figure out what these are. 13 says, how satisfied are you with the amount of hours worked per week? 15 says, how satisfied are you with the location where you work? So 13, 15. 18 was also Likert scale. Do you agree with the statement that my workplace is safe? And 20, do you agree that my workplace is inclusive? So notice here we have, these questions are all Likert scale and they all have a 5 scale. So what we do is create a spider or radar plot where we have 13, 14, 15, 18, and 20. So here we have 5 variables that are all Likert scale on a 5-point scale. And then what we're going to do is we're going to look at question 23, which is nominal, which is the north, south, and east locations. So we're going to create a copy of our data frame 2 with just these variables here. So notice they're all coded, including the nominal one is coded. And if you want to see here, we can just pull the head of the table. And here we're looking at the first 8. Remember the default, if you don't specify, is 5. So you can change it to something different. But by making it a little bit larger than the default, we can see the variety here. Question 23, 1, 2, and 3 locations. 13, 14, 15, 18, and 20, you can see range from 1 to 5. All right. Now what we're going to need to do is we are going to need to either take the average or pick individuals. So when you do a spider chart, I'm just going to show you what it looks like. This is a spider or radar chart. So here we have the ordinal scale that goes from 0 to 5. Here we have our different variables, question 13, 15, 18, 20. And what we need to do is decide, is this going to be the average response or is this going to be kind of example person? So we could pick, for example, we could pick 3 people, and for each of those 3 people, one from each location, we could look at how they responded to these 5 questions. So an example person from the north, an example person from the south, an example person from the east. And so then we can see with the spider or the radar chart is that we can see that this example person rates much higher in all of these categories than this example person who's rating much lower in all of these categories. So you got to decide, what are you trying to convey here? So let's start here with, and by doing this location, so these are each people, right? Respondent 0, 1, 2, 3, 4, 5. So if we take SPI.location 0, this is taking that index, this person 0, who is from location 3, so north, south, they're from east location. If we pull them, so let's call this person 3 because they're from the 3rd location, we're going to pull this, and what we want is we want this information here. We want to skip the results of question 23 because we're pulling this person as a person from location 3 by using index 0. That's what this is here. And then just output for us P3 locations 1 through 6. So when you do that, what you get is that their response to question 13 was 4, question 14 was 4. So we're essentially just pulling this piece right here for this example person from location 3, identifying that this is index 0. So we'll use this as an example of person from location 3. Then as we go through here, this next one here is person location 1. So the index is 1, and we want to pull just this 3, 1, 2, 3, 4. So that's what this is. Person 1, because they're from location 1. Their index is 1, and we're pulling just that 1 through 6. And so this is 0. That's why it's 1 through 6. And we're simply just using the next person in line who happens to be from a different location. So they're going to be the example of the north location. Okay, so that's what we have here, P1, person from location 1. And then we need a person from location 2. So as we look through this, we see here index 4. This is person from location 2. So let's pull them as an example. So person from location 2, the index is 4, right? Here's 4, location 2. And we want to pull this 1 through 6 here. So if we do that here, we can see we have pulled all that information from index 4 for that example person from the south location. So now we can create our spider or radar plot that shows our example people from those 3 different locations. We need to create the categories. So these categories here are going to match the order, question 13, 14, 15, 18, 20. So question 13 was about hours worked. So we're just going to simplify that as hours worked. And then we have question 14, which is time of day. Question 15 is location. 18 is safety, and 20 is inclusivity. So what we're doing here is hours worked, time of day, location, safety, inclusivity. Those are our categories. Then to create a spider or radar plot, what we're going to do is we're going to take our figure and we're going to use Go. Remember, that's our package here. Plotly.graph objects, we're calling Go. And then what we're going to do is we're going to create a figure using Go, and then we're adding components to that figure. So first we're going to add a trace, which is going to be a scatter polar, and it's going to use P1, 1 through 6. So you see where it says R equals, you leave all that, and the only part you change here is this P1, 1 through 6. Okay, we leave the theta equals category, we leave the fill equals to itself, and the only parts you're changing is this P1, 1 through 6, and we're calling this person 1, person from location 1. Okay, and then we're going to add a trace, use scatter polar. We're trading out this piece here, so this is going to be the information for person 2, and we're going to name it person 2. So the rest of it just stays as it is. Then what we're going to do is add another trace using a scatter polar. We're trading out here that it's the P3, person 3, so the information for their questions, and naming it person 3. The rest of this you are leaving as it is because this is all the formatting to create that spider or radar plot. So if I run this, if you were to do this with different questions, again, you would change those categories here based on what these questions are that you're choosing. You would change right here this P1, 1 through 6 to be the information that you've pulled here. And then the naming scheme, person 1, 2, and 3 is what we're using here. So this creates this plot here where person 3 is this outer plot showing that person 3, so north, south, east. This example east person is the most happy. And we can see then our other ones here, our other plots. So we can do a comparison of our example people. The challenge with the spider or radar plot is that while you can show how they felt on all these ordinals, we do only get a limited number here. And so this is example person 1, 2, and 3. You could alternatively shown kind of an average of the 3. If the averages are quite consistent, then you have just 3 the same image plotted on top of it. So there are quite a number of limitations to our spider chart. So you have to look at what are you trying to convey. The challenge, of course, here is that we just chose the first person 1, the first person from 2, the first person from 3. They may not be representative of the rest of the north people or south people or east people. Okay, so keep that in mind. What if we wanted to create a spider chart for each location? So we're going to create a spider chart for the north. So we're going to take our information and we're going to, if you go back our SPI, let's go back to our original table. So we had created this table that was a subset of the coded data set. So it was question 23, 13, 14, 15, 18, and 20. We could then separate this table into 3 tables, one where all the question 23 equals 1, one where all the question 23 equals 2, one where all the question 23 equals 3. And so to do that piece, we would separate it out. So we're going to take where our table, where question 23 equals 1, and we're going to create this spider table here north, spider table south, spider table east. Okay, so now we have 3 tables. So if we were to look at that, for example, SPI north dot head, you'll find that first column is all 1, and then we've pulled this here. Okay, so now what we can do is we can repeat our process. And here what we're going to do is instead of pulling our example person, what we can do is we can do some averages. So to do the averages, we're going to find the average for our 3 tables. So we have our north table, our south table, our east table. In this case, we can find the average for the north, the average for the east, the average for the south, instead of just our selected persons. Okay, so the difference is in your code, we still have the categories, hours, work, time of day, location, safety, inclusivity. We're still using Go to create a figure. We're still adding traces to that figure with the scatter polar. The difference here is that we're going to find the mean of the north table and call it north average. We're going to find the mean of the east table and call it east average. And we're going to find the mean of the south table and call it south average. Each of these has got the same categories. The rest of this is just that same formatting. So here, when we do this and we run it, we get a single spider plot, but what we have is instead of one particular person from each, we now have the average. So notice that our green is the south, okay? Our east is this orange color, and then you can see that there's kind of a hidden blue here, and that's because the average east and the average north are very similar, but the south is different, and so the blue one gets hidden away. So what this shows you is that the south is inconsistent with the other two locations for the average opinions, and that the average opinions are much lower for the south than they are for the other two locations. So we can see that the average in the south is different. Because averages, right, are averages, then you can see that it kind of hides the other one. So it's not as dynamic of looking at as this one here, but it's a better representation of the actual data because it's not just 3 random people, it is the average of all the people at each location. So there we have our spider or radar plot. All right. Now in this case, so let's just show you here, this is north average, then east average, then south average in terms of the order. And that order does then impact what is shown. In this particular scatter plot, we did means. You could alternatively do medians. So this is the same plot, the same order, but just trading out and doing a median instead of a mean. And so if we run this one, rest of the code's exactly the same. It's just the median instead of the mean. We can see here, you can see a little bit of a difference in the response, but again, you see that the third category is completely hidden because it's not that different between the east and the north. It is the south that's different. But notice the shape is a little bit different here in the south one. Little bit moved over because there is a difference between the mean and the median, right? So you can choose if you want to show the mean or the median, which one's more relevant to that. The other plot we want to look at, because again, we are focused here on, we are comparing with 3 or more variables. If we have 3 variables, and 2 of them are nominal and 1 is ratio or interval, we can create what is called a dot plot. So this only works with 3 variables when 2 are nominal and 1 is interval or ratio. So let's take a look at that. So to create a dot plot, we are using plotly.express, and we are calling it px, and then we're importing pandas as pd so that we can manipulate our create some tables. So in order to create a dot plot, we have 2 variables here, question 2 and question 23. And question 23 is the north, south, east location, so it is nominal data. And question 2 is the type of contract you have, part-time, full-time, again, nominal data. So in order to do this dot plot, you have 2 nominals, and then you have 1 that is interval or ratio. And in this case, that is the question about how many years have you been at the company. So what we're going to tell it to do is we're going to tell it to find the average number of years at the company. So question 24 is the one the average is being calculated for. And we're grouping it by, and here we have 2 nominal variables, question 23 and question 2. And then we're going to have it reset the index for that. So create a table for us. It's going to look like this. And so what we see here is that the north location part-time, the average number of years here is 2.57. If they are the north location and they are full-time, the average number is 13.7. So notice here we are using our coded data set. And we have question, let's just check here. What if we use the uncoded data set? So question 23 becomes north, south, east. Question 2 becomes our full-time, part-time. If you do that, the table looks like this. Okay, so we can do it like this, or we can have it from the coded data set. We go back to the coded data set. Then we have our numbers here. Okay, if we are using the coded data set, then we're going to have to replace them with the labels. If you are using it from the original data set, you don't have to do this labeling here. So if we just happen to have the coded data set we're running, then we're going to need to replace it. So we're going to need to make 1 north. So it's going in, finding question 23 in our count sum table, and it's going to replace 1 with north, 2 with south, 3 with east, and we're doing it in place, which means we're not creating a new variable. We are simply replacing it in that current list. For count sum Q2, we would replace 1 with part-time, 2 with full-time. So if you're using the coded table and you're doing this dot plot, you're actually going to have to put it back is what you're doing. So we would do this to create the table. The table is numbers. We are then replacing those numbers with their values. If instead you had used DF, not DF2, you would already have that, as we just saw. So either way, you need the words back. So that way that your table looks like this: north, south, east, and question 2 says part-time and full-time. Either use the original data set DF or replace the codes back with the original words. Once you've done that, you can create your data plot. So we're going to say figure equals, so we're giving the plot a name. We're going to use that PX, that's the Plotly Express, and we're going to use the graph called scatter. When you do scatter, you need to specify Y and X. So notice here the Y is the nominal data, that's the north, south, east location. And X question 24 is the interval ratio. So it matters which one you put where. Y is going to be the nominal. That's our east, south, north labels that we have here. And then we have X equals 24 is going to be the years of the company. And then we have a second nominal variable, and that is the part-time, full-time. So the color coding is going to be where the second nominal is. So that's why symbol equals Q2. So the second nominal variable is the one that gets colored. So really, in terms of simplicity, whatever has the most categories should be your Y, and whatever has the least categories should be your symbol, just to make it easier to read, right? So this is better here if this is just binary. All right, so then we're going to update our graph by adding some traces, and then we're going to have marker size equals 10. So what we're doing here is that we're making these bigger, and then we're going to update the layout to have the x-axis have title years at company, the y-axis be location, the legend title is workload. So we're adding those variable names to the graph. And then we make it show the figure. So what this shows us is we can compare the blues. These are the part-timers. So notice the north part-timers stick around longer. The south and east seem to be about the same, less than 2 years. And for the full-time, we can see that the north locations stick around the longest, and that the south location, the full-time, don't stick around as long. You can also see the difference here for the east in terms of how long the part-timers have been here versus the full-timers. So we can compare across question 23. We can compare across question, question 2. And here all of it is allowing for us to look at ratio or interval data. So a dot plot has 2 nominal and 1 interval or ratio. And in this case, you'll recall we're looking at averages. You could change this and look at the median instead. So we could change this to be median. Everything else is exactly the same, so we just rerun. Because we didn't have the coded data originally, or sorry, because we had coded data originally, we had to put that code back in. So now here's the median instead of the mean. My face is covering up the north, that's at 12. You can see the medians are the same for the part-time. We could, if we go to mean here, and I'm just going to use DF, so the non-coded, we get our count sum here. It's already labeled, so we don't have to do any of this replace. This already exists. And then we can graph here. So if it is unlabeled, you don't have to do that extra step of putting those, if it's uncoded, you don't have to do the extra step of putting the labels back in terms of seeing that dot plot.